So hello everyone and welcome to my channel. In this video we'll be discussing about Prentice rule. So before we start with the video, I want you to know about prism diopter, which is denoted by this sign. Suppose you have a prism which is placed 100 centimeter far away from the screen, and if you want to know power of this prism, so you have to measure the decentration which is this prism is causing, and formula for calculating prism diopter is deviation in centimeter. Suppose your prism is making 1 centimeter displacement when screen is 1 meter away from the prism. So this becomes 1 prism diopter. So if your prism is making 2 centimeter displacement when screen is kept 1 meter far away from the prism, there will be 2 prism diopter. Now we'll come back to our main topic, which is the Prentice rule. Suppose you have a plus lens which is decentered c centimeter downward. The parallel ray, instead of passing through the optical center, now passes through a point which is above the optical center and is denoted by point A. After passing through the point A, the ray bend towards the optical axis and meet a point F, which is also the focal point of this lens. The distance between focal point and the lens is the focal length of the lens, which is denoted by F in meter. A screen is placed 100 centimeter far away from the lens to measure the prismatic effect which is caused by the decentration. If you see this triangle, which is ABF, this is a right eye triangle and there is an angle theta. As it is a right eye triangle, we can apply tan theta formula. Tan theta is equal to perpendicular by base. Perpendicular for us in this triangle is FB divided by, and base for us in this triangle is AB, which will be equal to decentration in centimeter divided by our focal length in meter. So this is equation 1 for us. So next we're gonna take triangle A, D and E. So this triangle we're gonna take. In triangle A, D, A, tan theta is equal to, again, perpendicular by base. For this triangle now, perpendicular is this one, displacement in centimeter divided by the screen distance from the lens, which is 1 meter for us. This is equation 2. As both triangles have similar angles, therefore we can say C centimeter by F meter is equal to displacement in centimeter divided by 1 meter. But we know prism diopter is equal to deviation in centimeter divided by distance in meter. So this side is equal to prism diopter. So this side is equal to prism diopter. So we can see decentration in centimeter divided by focal length in meter is equal to the prism power. So this formula is further simplified as C multiplied by F, where F is the focal power of the lens, C is decentration of lens in centimeter. So this is the formula to calculate induced prismatic effect which is caused by the decentration of the lens. So this formula is going to give us induced prismatic effect which is caused by the decentration in prism diopter. But what will be the base direction? So prism base direction with decentration depends upon two factors. One is the direction of the decentration and other is the whether the lens is convex or concave. So a plus lens can be considered as a combination of base to base prism which is also causing the convergence. So suppose you have a plus lens which is perfectly well centered on the cornea, mean the optic center is matching with the patient visual axis. So there will be no prismatic effect induced. But if lens is decentered downward, so there will be a now base down prism created in front of the eye. So there will be a now base down prism will be created in front of the eye. This lens decentered upward, so there will be base up prism created in front of the eye. Okay, same happen with the horizontal decentration also. If eye visual axis is passing through the optical center, there won't be any prismatic effect. But if lens is decentered outward, there will be a base out prism created in front of the eye. If lens is decentered inward, so there will be a base in prism created in front of the eye. A minus lens can be considered as a combination of two apex to apex prism which also cause divergence. Same way here also, when lens optical center is perfectly centered with the patient visual action, there won't be any prismatic effect induced. If lens is decentered downward, there will be a base up prism created in front of the eye. So if lens is decentered upward, so there will be a base down prism created in front of the eye. If lens is decentered outward, there will be a base in prism created in front of eye. If lens is decentered inward, there will be a base out prism created in front of eye. For easily to remember this, if plus lens decenter, base direction will be always towards decentration direction. If minus lens decentered, so base direction will be opposite to decentration direction. So here's one example. If a lens is having a power of +3 diopter, is decentered 5 mm outward from the center of the eye, how much prismatic effect and what will be the base direction will this cause? So to calculate the prismatic effect, we know formula. Prism diopter is equal to decentration in centimeter multiplied by focal power in diopters. And given to us decentration is 5 mm, which will be equal to 0.5 in centimeter. So here we gonna multiply 0.5 with 3, which will be the prismatic effect induced. But what will be the base direction induced? As the lens is decentered outward, so the which will be created in front of eye is the base out prism. So we gonna write here as the base out. This is the final answer problem which was given to us. So everyone, I hope you liked the video. If you like the video, please like and subscribe to my channel. If you have any queries, put it in the comment section. I'll be happy to reply them. Thank you.